Welcome to Flink Forward Asia 2024.
Next, we have Flink for everyone, running your first Flink job locally with YAML Beginner's Perspective. Ini sesinya akan dibawakan oleh Bapak Mahendra Oksa Pradana as Data Engineer Singaporean Multinational Tech Company. Kayaknya ini banyak pendukungnya, mana pendukungnya, boleh dikasih tepuk tangan. Langsung aja kalau gitu kita panggilnya ada Mas Mahendra Oksa Pradana. Ini akan nyanyi dulu ya, nyanyi dulu.
Oh yeah. Okay, good afternoon everyone. So how is it going? I mean, we already almost reached the end of the breakout session. So hopefully you still excited to know more, learning more about Flink especially. So today I would like to bring another topic related to Flink, but I think it's quite different with the previous talks, which probably more theoretical and more deep dive into the fundamentals. But in this time, I would like to more practical. So yeah, for the topic itself, as have been mentioned by the MC, so I would like to bring Flink more into inclusive for everyone. So not only for engineers, not only engineers that can create a Flink job. And then the second one is related to the locally. So why I put locally? Because I want everyone to able to try to create their first job without need to worry about the cost. So that's why I put the locally. And the last one, beginner's perspective, because I'm beginner, that's all. So first of all, I would like to introduce myself. My name is Oksa. My full name is Mahendra Oksa Pradana. So currently I'm exploring the tech realm for 4 years, and currently working as data engineer in one of Singaporean multinational tech company. So, and then in the free time, I also manage a community called Data Engineering Indonesia. And the last one, this is quite a fun fact. I mean, this is my first time becoming a speaker in a Flink conference. Because why I submit the proposal, because it's challenging. It's pushing me to the limit. So I would like to test myself if I am qualified or not. So what will we discuss today? There are several points. First of all, what is Flink? Actually have been discussed in the beginning of the breakout session, so I don't want to put too much attention on those part. And then the second one is Flink architecture. Also have been discussed earlier, and also Flink connectors API and demo, local Flink resource usage, and what's next. And probably Q&A if we have free time. But I hope we can do Q&A at the end. So what is Apache Flink? So yeah, I take it from the official documentation. So it's open source framework and distributed processing engine. So it has master and some workers that working distributedly and do the computation over unbounded and bounded data stream. So unbounded here is streaming, as we know that the data is keeps coming over and over again. So we only have start date with no end date. So the data keeps coming, while bounded itself is the opposite one. It's more into batch instead of real time. So it has start and end interval. So let's say from yesterday at 12 until today at 12. Yeah. and then for the architecture, when I first learning Flink, I was remembered about Spark. Yeah, I think all of the like master-slave architecture approach is quite same. So in Flink we have job manager, which acts as the master. In Spark, I think they call it a Spark driver. And then we have several task manager or workers. And in Spark, I think they call it as like Spark worker. And each of job manager can have like multiple task managers. So, and then yeah, this is more into the detail of architecture. So every worker can share their data between each other, and then we have a Flink program, which is like our code that we can submit like through local, through command line, and then our job will be received by the job manager, and then the job manager will do some assessment to distribute and to schedule. So job manager has scheduler, which used to schedule the tasks into a task slot. So yeah, task slot is like the smallest unit of tasks in a Flink job. So, and then yeah, Flink has some deployment mode. The first one is application mode. So, and then the second one is per job, and the third one is session. So application mode is, so the job manager will only there if there is any jobs being submitted. So once the jobs is done, the job manager will exit. And then per job is quite the same. So job manager will receive some tasks like from jobs. So yeah, and then it get exit. So and then the last one is session mode, which is the job manager will not exit. It will be there like as long as it's still, the job manager is not being killed or terminated. It will not like only there if there is any job, and then we can submit like n number of jobs to the job manager so that it can receive as much as Flink application or Flink jobs. So, and then there are several APIs in the Flink. First one is table API. The second one is data stream, and the third one is data set, which is, as far as I know, is being deprecated, and the Flink documentation recommend us to use table API instead. So table API, it's more higher abstraction, like offering us with SQL command to perform some batch or streaming use case, where data stream is more lower abstraction. We need to write some code, but it offers us with more customized logics, unlike the table API. So yeah, and then for this demo, we will use the data stream API. So as far as I know, data stream API is faster than table API because the table API is usually like will be since it's higher abstraction, so basically it will be translated into a more lower one. Yeah, and then what is the differences between the API? So as have been mentioned earlier, so the more higher of the level of abstraction, usually it will become slower. So as we can see here, table API is higher than the data stream API. So it's usually becomes slower, but it offers us with more, with easier implementation. So, and then as we can see the below one, we can see that SQL or table API is more concise, but it lacks of expressiveness. So it's like quite strict because the operator, the function is quite limited, so we depends on the function that they offers to us, while the data stream is more like less concise but more expressive. Yeah, so yeah, this is actually my personal rating for if we compare like which language can we use to write Flink job. So I think for Python we will have high developer experience because Python is easier to learn, easier to write, unlike Java and Scala. But in terms of performance, since it is interpreted language and then it doesn't run natively on GVM, so it will have like performance degradation compared to the Java and Scala. And also since Flink is basically natively on on Java, and that's why Python is not that good in terms of feature support. And if we see the second one, which is Java, probably I think for the developer experience is not as good as Python because the syntax is quite complex. But for the performance and feature support, I think it's the best because as I have been mentioned earlier, Flink is natively run on top of GVM. So Java and Scala will have quite similar in terms of performance. But if we see the last one, which is Scala, I put the developer experience for Scala is higher than Java, but still lower than Python because in terms of syntax, I think Scala is like half of Java and half of Python. Like we can see some of Python syntaxes there, but also we can see some of Java syntax there. So I think it's easier to learn than Java, but it's not as easy as Python. And in terms of performance, because Scala is also run on top of GVM, so it will have quite good performance. I mean, quite similar with Java. And in terms of feature support, the community is also put their attention more to the Scala instead of Python. But as I read on the documentation, Flink community decides to deprecate and remove the API support for Scala, probably in the future version. I think it's 2.0 because earlier we saw a presentation about the Flink 2.0 that being released like next year. So as the team, yeah, because the reason is the team want to focus to the Java instead of Scala. Yeah, okay, I think that's all for the introduction of Flink. So we will go to the demo. So as for preface, we assume the events or data is produced by another applications. Like for example, we have a mobile team, let's say, that produce some events to Kafka, and then we will read those events, Kafka events, and then we will sync or ingest those Kafka events to another topic. So, and then we will use Flink data stream API, and then also we will use PyFlink so that as my topic goals, which is to enable the inclusivity of Flink. So with PyFlink, since it's easier to learn and to write, so hopefully it can lower the barrier to entry. So, and then to simulate the scalability while we get the zero cost, we will leveraging local Kubernetes cluster for our Flink cluster deployment. So we will not use any cloud manage for the Flink, but we will use only for Kafka. And then, yeah, actually I used the free trial. So I can say that I didn't pay anything to write this, to prepare this demo. Yeah, as for the preparations, there are some things that we need to prepare. First one is the Flink binary to submit the Flink job to the cluster. And then second one is we need to download the Flink Python API using the pip. Like ensure, please make sure the version is same between the Flink API, between the Python API and the Flink binary, because if it's different, it will cause any disturbance or error during the submission, during the job submission. And also, since we are using local Kubernetes, we need Docker. The most convenient one is to use Docker Desktop. And then we can install Kind or Minikube based on your preference to run the local Kubernetes cluster by leveraging the Docker containers. And also download the kubectl to interact with the cluster. Also, the last one is to download Maven to build the jar. So because we will build a new jar that consists of multiple jars. Yeah, so the architecture of the demo is quite straightforward. So we will have a YAML file that it will get read by our generator, and then the generator will also read Jinja template, and then the Jinja template will get rendered based on the YAML file, and then the result will be right into .py. So for example, it's like flink_jobs.py, and then after that, any user can submit the Flink job with Flink run -m, and then the job manager URL with its port, and then -- Python, the name of the Python Flink file. And then if we want to include some dependencies like utility or helpers function, we can include with --py files, and then --jar file if we want to include some jar as like the library. Yeah, and then as we can see here, so from this YAML, like for example, we have a demo application or demo job, and for the configuration of Flink, we set the max parallelism with 2, and then for the Kafka, we set the broker URL, the topic source, the topic sink or the destination, and consumer group, and also the offset. So with this kind of YAML configuration, we can get a job being submitted in the UI. So from YAML, we can see a running Flink job in our local. Yeah, and yeah, this is like just for sake of the proof, like we are able to submit the job to our local. As you can see there, the URL is localhost, meaning that our Flink is deployed on the local. And also, this is our cluster, Kafka cluster using Confluent. And yeah, this is the topic source. We give a name sample pizza orders, and then they have some of JSON file, JSON data, and then it being ingested by connectors of Confluent, and then it being ingested to pizza orders promo. So as we can see here is the data is successfully being ingested, and then yep, since talk is cheap, let's go to the code. Yeah, so I will start with the template. Wait. Yeah, so in this template, we will write a super simple script, which is the script will read a source from Kafka, and then we will set like the topic's name, the server, and then the consumer group, and then the offset of start, which strategy that we use to read the event from the Kafka, and then we set the deserializer to deserialize the records from bytes to JSON. And then we set some properties just for authentication purpose. And then for the sync one, it's quite similar. We also define the broker URL, and then we set the record serializer, because when we want to write another Kafka, we need to serialize the data, and then we use string serializer, and then this the rest is for authentication to the Confluent Cloud, and then we just need to define the source and destination or sink, and then we can just execute the job. So as simple as that. There's no transformations here, and if we look at the generator, so basically it will read the YAML file. The YAML file is stored in the resources, and then in resources we can see that we only need to define this of things configuration, and then from there we will define, and then from there we will render the YAML into a Python file, into a new Python file, and then we just write the Python file, and then this is the result. It's totally similar, it's totally same, just some value being rendered. For example, the topics. In the template, we can see that the topic is not defined. We use the Jinja template, and then the Jinja template will read from this YAML. For example, like kafka.broker URL, and then it gets rendered into this file, Python file. And then since we need some jars, as I've been mentioned earlier, so we need 2 jars. The first jar is used to do authentication to the Confluent. So we use that one. The first one is for authentication, and then the second one is to connect, able to connect with Kafka. So the first one is for authentication, the second one is for Kafka. And we define both of the jar in here, so we create a pom.xml. So it's like defining which package, and then what is the library name, and then the version, and so on and so forth. And then we just need to build using Maven. So it's like Maven. MPN. Yeah, need to like we just need to MVN clean package, and then the pom.xml here will be generated, will be built into jar files, which I put here. So the name is let me check. So so it's being written into the target, this one. So the result is this jar, YAML Flink demo jar with dependencies. So this is a new jar that I created based on the pom.xml here, using Maven to create the jar. And then to submit the job, we only need to use this command. Like first of all, we need to call the Flink binary. So .flink and then the version, and then we can use like Flink run, and then we target which job manager URL. Since we are in local, we will use the local host, and then we will include which Python file we want to run. Which Python file we want to submit alongside with the other dependencies. So if we want to include some utilities, for example, we want to add some helpers function to help our implementation, we can include this by compress the file into a zip. So compress this util file as a zip, and then we can include the zip using py files. And then for the jar itself, we can use jar file to include our jar that has been created before. So with this, we can see that the job has been submitted, and then we can see from the Apache Flink dashboard, the job is being submitted, and then we can see for errors here, if any, and we can see the logs from the job managers, like so. Yeah, so as we can see here, the Flink job is able to read the data from sample pizza orders with 3 partitions, and then it's running the sync like from Kafka to another topic. And if we see on the Confluent Cloud, so this is our topic source, and then this is our topic destination or sync. We can see that the topic sync will have the events that comes from the topic source. Yeah, so it's like, the JSON is totally same, exactly same, because we don't use any transformation here. So yeah, with this YAML, we can generate a job to doing some Kafka to Kafka synchronization. So yeah, and then I use Kubernetes. So I use kind to create the cluster, and then I use the rest one is the rest of manifest of Kubernetes manifest comes from the official documentation. So for example, this deployment, I use the official documentation, and then for the task manager as well, so we can set how many task manager we want to have, and then we can put the configuration like how big the memory, how big the CPU, and then like how many parallelism, and then how many number of slots of within each of jet task manager. And then this is for the cluster configuration, and yeah, this is for the service to publish the port so that we can see the UI, and then we can submit the job. And yeah, I think that's all for the demo that I can show. So yeah, apart from the demo, I have an idea to check what is the resource usage. So yeah, the configurations I use from the official documentation. So it will spawn a job, one job manager, 2 task managers, each has 2 slots, and then the memory of job manager is 1.5 gigabytes, and for the task manager it's 1.6 gigabytes, and for the parallelism is 2. So, and then the throughput of the producer is 2 messages per second, so it's very small, but for the sake of like learning or like trying to interact with Flink, I think that's totally fine. It's free though. And then for the resource allocation, I use CPU, 2 cores for the CPU, and then 4 gigabytes for the memory. And yeah, as we can see here, so for this, in this screenshot, I submit the job at 1:48, and then so from the dashboard here, so the red triangle, for the red square here means that the job is starting from the red, so it's like around 17 past 1. So before that, the job has not been run. So there is, I think there is no much like performance or usage differences before and after we submit the job. And then this is for the control plane, like the master of the cluster. And then this is for the worker of the cluster. And then if we see from the dashboard previously, before I submit the job, so before 17, the average number is around 1 core out of 2 cores, which is like 50% of usage. And the average memory is also 50%, 2 gigabytes out of 4 gigabytes. And after 19 p.m. when the producer was resumed, so actually the producer is from the Confluent Cloud, and as we can see here, the average number of CPU is 1.3 out of 2 cores, which is like a bit higher than 50%. A bit lower than 50%. And then the average of memory usage is 3 gigabytes out of 4 gigabytes. So what does it mean? So I can say that with this minimum specifications in our local laptop, so there is no any cost we will need to pay to try our Flink job, and we still able to run the Flink job without any additional cost. Yeah. So, and then what's next? This is from my perspective. To be honest, I think most of them already discussed earlier, like the watermarks that we can use to capture the event time, and then the complex event processing. We can use to like handle some event, and then the checkpoint and save point, like what have been discussed earlier, to like, for example, like when you're in playing games, you can checkpoint to save your state, and then you can go back to your state when everything goes wrong. Let's say when you're killed, and then you want to restart your game, you can resume from your checkpoint. And then some operators which related to the transformation. So like for example, as map, flat map, and then key by, and so on and so forth. And then the last one is async IO. Yeah, this is for the references that I use. Most of them is from Flink officials, and the last one, which is I think not many people mentioning it, even though it's really useful, but I think most of people didn't write it on the slide. Yeah, and then I think that's all for me. If any questions from you guys, feel free to ask, or after this session as well. Yep, thank you.
All right. Do you want to have any quiz or Q&A? Ada yang mau ingin bertanya mungkin?
Yeah, probably we can start with the question first.
All right, we have one there and another one. Going once, going twice.
If no, I think I will go with quiz. One question.
Quiz,
yep.
one question. Please identify yourselves first,
Okay.
sir.
Thank you for the opportunity. My name is Gabriel Lai. Especially I invest in IT security company also.
Yep.
Maybe I want to combine both, technical and business integration point of view, basically. Maybe from your insight, it's very good, especially for Indonesian business. Maybe you can share with us maybe what challenges might Indonesian business, especially for Indonesian company, faces when they want to adopting Flink, especially for real-time data processing.
Oh, okay. Yeah,
Thank you.
Yeah. Thank you. So it's great question. I didn't expect that will become so. But if we talk this, first of all, disclaimer first. This is from my perspective, so I don't talk on behalf of the company. So from my perspective, the challenges that, well, if you talk about the Indonesian specifically, I think, first of all, I think we need to ask first whether the company really needs streaming or not. So because from my perspective, as long as we can handle those in batch, just use batch, no streaming, it's fine. I mean, we don't need to follow the fancy technology like the state of art of, this technology is becoming viral and most of the companies using it. But we need to ask first, like, why they are using it at the first place. Like, we should be think like, I think they use it because the use case need to be used streaming instead of batch. Batch cannot do anything with our use case. Let's say, for example. So I think that's the first point. I think the second point, if we talk about the Flink especially, I think it will be good to like comparing with like, especially for example with Spark streaming, because Spark has also a streaming API, so that we will come into a conclusion that maybe for our use case Spark is better instead of Flink, or I think we think Flink is better than Spark. So we need to do some POC of course, and then what are the other challenges that we might face is, I'm not sure, because for the technology or the technical perspective, I think we can learn anywhere for Flink. Like for my case, I use AI so hard to learn Flink by myself. Like combining with the documentation, with AI, with the forum, yeah, we can learn Flink like independently. So I don't think that we will have any challenges in terms of technical. But the thing that I want to highlight is more into the business side. Like, do we actually need real time? And if yes, what are the requirements? Like, is there any SLA? Like, should be it like triggered, or should we have like any triggers or any actions within a split seconds, instead of like, okay, probably 1 hour, 2 hours is fine, so we can use batch instead of real time, because real time is really consuming, I mean in terms of cost, and then in terms of like our workload. Like, let's say for example, real time will always run. It will not have any end time, unlike batch. In batch we can, in batch we only care about, okay, this job is run for a specific interval. Let's say from yesterday to today. So other than that, we don't need to focus. We don't need to care about the batch. Yeah, I mean, if real time, the job is always running, meaning that if anything goes wrong, we need to immediately fix the issues, which will needs more effort, needs more workload, so it's painful for the real time itself. And so yeah, my point is, if we can solve with batch, just use batch. If we need to use real time, please gather as much as requirements, what kind of real time that you want, how fast you want the result to become. Yeah, I think that's all from me.
All right, thank you for the question, sir. You got your iPad there. Okay, I think it's finished, or you want to give one?
Yeah, I think
quiz?
one quiz to close this session for me.
The hardest one, please. No.
Yeah, I just want to test your attention, actually, like,
Yeah, sure.
does anyone know which language that I used to write the Flink job?
Ooh, yep. The guy over
Yeah,
there.
the guy with pink clothes.
Eh.
Python.
Python. Yeah, yep, you
It's
got it
correct?
right. Yep,
Yay!
correct.
Kulkas 10 pintu buat Anda, Pak. Alright, thank
Dibagi
you.
dua.
Alright, thank you so much, Mas Oksa. Thank you.
Thank you guys. Have a nice day.